If you are building web apps, whether front-end or back-end, you're probably fine using Postgres or another transactional database for most of your use cases. But as soon as your app needs data-intensive features like analytics dashboard for user or insights on product usage, things can slow down. That's because transactional databases aren't built for complex analytical queries. In the past, you would often hand this off to a separate team with a specialized setup, but today infrastructure is simpler and SQL has become the go-to tool for analytics, which makes the whole thing more accessible. In this video, we quickly cover what analytical databases are, when to use them, how to move data from your OLTP database, and a practical example of using an OLAP cloud services like MotherDuck, which is DuckDB in the cloud, directly in your Vercel application. Let's start with what an analytical database is. Analytical databases, or OLAP databases, are designed for querying and analyzing large datasets. Unlike transactional databases like Postgres, which is great at handling fast and small-scale operations like creating and updating records, OLAP databases are optimized for heavy read-intensive operations. They are built for complex query like calculating average across millions of rows, filtering data by multiple criteria, or aggregating metrics over time. They're also much faster at these operations because they store and process data differently, typically using a columnar storage. In short, OLAP databases are ideal for scenarios where you need to crunch large datasets to find trends, patterns, or insights. So when to use analytical databases? First, it's important to know that it's perfectly fine to start prototyping your analytics use case on your current transactional databases like Postgres. Many analytical projects begin like that, especially for smaller datasets or simple reporting. However, as your application grows and the complexity or volume of data increases, you likely hit a performance bottlenecks. That's when you should consider moving to an analytical database, as you don't want these analytical queries consuming all the resources of your entire database. So here are some common scenarios for analytical database. First, user-facing analytics. If your application needs to show user detailed analytics like tracking usage, trends, or performance metrics, OLAP databases make it easy to generate fast interactive reports. The second one is product insight. If you want to understand how your users are interacting with your application, like which features are most popular or what leads to churn, OLAP database lets you run exploratory queries efficiently. Yes, there are a lot of tools to cover product insight, but at the end of the day, you're gonna have data that you need to crunch, and owning this data in your own databases will give you much more freedom. The third one is combining data sources. If you need to merge data from multiple systems like CRM data with application usage data, an analytical database simplifies this process by handling large, diverse datasets. These use cases are not exclusive, of course, but are the most common ones you might see. Now, how do you actually get data into an OLAP database? Let's cover at high level 3 common methods. The first one is ETL pipelines. ETL stands for extract, transform, and load, and this is a standard approach to move data. You extract it from your OLTP database, clean or reformat it, and load it into your OLAP database. You typically have a separate process in Python or whatever have you that would move that data. There are two classic approaches. Either you directly query the OLAP system, you can process and load data directly into the analytical database, or you offload to an object storage. You can write your data to an object storage like AWS S3, and this gives you more flexibility to process the data later, be free on the processing tool you want to use instead of leveraging the OLAP database directly. The second is real-time streaming. If you need live update for dashboard or analytics, you can use real-time streaming tools like Kafka or AWS Kinesis to move data. These are event streaming service, often integrate with change data capture, CDC tools, to track and stream the change in real time. They're really great for incremental updates and syncing them efficiently into your OLAP database and your OLTP database. And finally, the third way to move data is by direct querying from your OLAP database. Some OLAP system allows direct query to your transactional database without moving data or rather relying on another process. So for example, DuckDB is Postgres scanner. With DuckDB, you can connect directly to Postgres and run analytical queries on your existing data. pgDuckDB extension is another method. This is a new Postgres extension that embeds DuckDB directly inside Postgres and is allow you to leverage DuckDB analytical capabilities without additional infrastructure, so within Postgres, but also to connect to MotherDuck directly. So each method depends on your application needs. Real-time streaming is ideal for live dashboard, ETL is great for batch analytics, and direct querying works really well at smaller scale use case as it's really easy to get started. So let's now dive into an example of how you can connect your web application to an OLAP database in your data stack using Vercel and its native integration with MotherDuck, which runs DuckDB in the cloud. If you're not familiar of what is DuckDB and MotherDuck, I would recommend you to check the video I'll put in the description. So in this use case, we'll hydrate analytical data stored in MotherDuck to feed directly into your application. With the native Vercel integration, you can create a MotherDuck account without ever leaving Vercel, streamlining the process with a single platform for both setup and billing. To start with the integration, just go to the marketplace listing and pick MotherDuck. If you want to start from a template, you can head over the template listing and you can deploy a ready-made template that query data from MotherDuck. So in this video, we are showcasing a Vercel data dashboard, and as you notice, it's incredibly fast and responsive. And here is why. It's leveraged MotherDuck Cloud for handling larger queries, and second, it used DuckDB WASM, enabling an analytical database to run directly in the browser. So this approach takes advantage of the client's processing power, reducing extra I/O traffic, and the result is a smoother experience for the user and a lower compute cost for developers.
So let's deploy this example directly in our Vercel account. So you just go over the template and click on the deploy button, and we're gonna follow the step from there. First thing to do is specify which repository you want to clone to. And then basically click on add the storage for the MotherDuck integration. Here you're gonna specify the tier you wanna start. You can start with the free tier. And finally, you give a database name, behind the scene, a new organization and a new account in MotherDuck is gonna be created. And also a database with the same name that you just gave. So you can see everything is deployed on my Next.js dashboard. I can go on the storage tab and see the MotherDuck here integration. And we have directly two types of token populated. I'll leave you more information exactly about the difference between MotherDuck read scaling token and the normal service token. But these two are essentially all you need to connect your application to MotherDuck. The MotherDuck token is a standard token for read and write, and the other one is really for mean to read application.
To wrap up, analytical databases unlock a world of possibilities for web developers. They help you handle data-intensive features like user dashboards, gain deeper insight into your products, and combine data from multiple sources, all without overloading your transactional database. And with modern tools and SQL as the common language, setting up these workflows has never been easier. It's just a click on a template. So take care of your OLAP databases and keep quacking.